in power quality monitoring held by our company صعب RDS, شركة صعب لأنظمة البحوث والتطوير. We are organizing this workshop with our partner Elcom from Czech Republic, represented by Dr. Jiří Hula, who's the head of the Power Grid Monitoring Department at Elcom. And he will be covering the latest technologies and solutions in the domain of power quality monitoring. المحاور التي سنتطرق لها اليوم هي كالتالي: ما هي جودة الطاقة ولماذا يعتبر قياسها ضرورياً؟ المعايير الدولية لجودة الطاقة الكهربائية، عدادات جودة الطاقة، الخيارات المحمولة والثابتة، البرمجيات الإلكترونية لجودة الطاقة، ثم سننتقل إلى العروض الفنية الحية وننتهي في الأسئلة والاستفسارات. So please next. So we at صعب RDS, we want to be a trusted partner in your technology journey. We are your technology advisor and solution provider that builds world-class innovation ecosystem to solve complex problems. So we deliver cutting-edge, sustainable productivity solution to industry, and we bridge the gap between industry and academia. So as you can see in this slide, as SAB RDS, we are directly involved in
recording in progress.
We are directly dealing with multiple sectors, from industrial IoT solutions to IP development and acquisition, human capital development, energy systems, and electronic defense application. So next, in the Dr. Jiří. So as you can see here, during this webinar, we want to explore and discuss latest technologies that can bring in new revenue streams to your industrial and engineering integration companies and users with the help of SAB RDS and Elcom. So we, as like platform provider with the hardware software platform and our vertical domain expertise from SAB RDS and Elcom, we want to be your local partner, as you as system integrators with your local capabilities, or as an end user to tackle a customer defined system. So we want by the end to be, or to help you to accelerate the journey toward your strategic objectives and the Kingdom Vision 2030. So we need to enable you to become leader in Industry 4.0 technology and energy systems. Now I will end this introduction, and I will give the mic to Dr. Jiří, who will be start the agenda related to power quality and energy monitoring. Dr. Jiří, the mic is yours.
Thank you. Good morning to everybody. At first, let me thank you that you allowed me to present our solutions and ideas in power quality measurement. At the beginning, some short agenda. So at first, I will very briefly talk about what is the power quality, what are the international standards. Then we will talk a little bit about the portable analyzers, then the meters for the fixed installation. Then I will present our central solution for the data analysis, and we'll have some live demo of the central software. And at the end, we will have some time for a discussion and questions. Very briefly about our company, we are based in Czech Republic, and we are working in electrical and test engineering for more than 30 years. Actually, I work on the power quality team for more than 20 years. As I said, we are based in Czech Republic. We have more than 200 employees and the revenue around 15 million euro each year. We have 6 locations in our country, but we are also active worldwide. So we have a lot of installations and partners, let's say, in every continent. Besides the power grid monitoring, we are also doing a lot of special stuff for testers and vision systems. We are developing software, doing some electronic designs. Also, we are producing some equipment for the transmission and distribution networks and some other power electronic devices. And at the end, we are doing some high-end test beds and drives for electrical products like large motors or similar. So now let's talk about the issue of this webinar. So the power quality. The power quality is some, let's say, imaginary word, but you should take care of the electricity as any standard product, because it's the same thing like you are buying bread or whatever in the shop. It should follow some requirements. So for example, the voltage level should be fixed or, let's say, stable. So for example, you should have 230 volts, no more or no less. For sure, on other voltage levels, it should be 400 kV or whatever. So this level should be stable. Also, there shouldn't be too much higher harmonics, for example. Also, the frequency should be somehow stable. So if you have 50 or 60 hertz network, so the frequency shouldn't be like 55 or 45 or whatever. Also, there should be 3 phases available, and it should be symmetrical. So same angle between red, yellow, blue phase, and all phases should be somehow similar. Also, the electricity should be available, so no blackouts. And there are many, many other parameters which can be called as part of the power quality. So as I said, the electricity is a product, so it should follow some standard requirements, which are called the power quality. For sure, we will never have all the time 230 volts very precisely because the grid is fluctuating. So these parameters should be in some limits, let's say. And what will happen if the distribution or transmission is not providing the good power quality? It's a good question. You cannot say very easily that if some parameter is wrong, that something will not be working. But in long-term view, definitely if, for example, the voltage is a little bit higher or lower for a longer time, then it can damage some equipment. Especially today, all the production and the facilities are based or using very expensive robots, computer-driven machines, special power devices, and they are very, or might be very vulnerable for the voltage or power quality. So in case of some short dips or swells, these can even damage or destroy the equipment, which is very bad, because if you have your factory with like 100 robots on the line and few of them breaks, then you stop the whole factory and you are losing a lot of money because you are not producing. So some wrong parameters also leads to loss of production. Also, the equipment can have much shorter lifetime, because if there is high burden on this equipment from the delivered power to them, so higher harmonics, whatever, then the device will not last for 10 years, but just for 2-3 years. I saw, well, maybe in the industry, it will not shorten the lifetime that much, but still it has some influence. I saw a lot of situations where people are buying their TVs or fridges each 2 years, and they don't know what happened, and the warranty is already over. But at the end, by the measurement, we realized that there is wrong power quality, a lot of voltage events, and then people are paying for a new TV each 2 years, which is very bad. So a lot of equipment can be damaged by wrong power quality. On other hand, your factories or your consumption, if it's not well engineered, it can also harm the power quality of the grid itself. So, for example, if there are some welding machines or something with really huge power input, then it can generate a non-sinusoidal current, and these higher harmonics on the current, if they are high enough, they can generate also higher harmonic on the voltage on the grid. So definitely it should be important to measure the power quality, at least to understand if everything is right or not. So this leads to question how to measure and how to evaluate the power quality. This power quality issue is developing for last, I don't know, 30, 40 years. For sure, from that times, a lot of industry changed, a lot of industrial standard changed, because also the production and the distribution and the consumers are different from the electricity point of view. So many international standards were developed. The most comprehensive one I can say is 61000-4-30 edition 3, which defines how the power quality should measure, what it should measure, what should be the precisions. Also, there are additional standards like 4.7, 4.15, which defines how, for example, harmonics or flicker can be evaluated. And also, there is one more international standard, 61586, which also defines how the power quality meters should be tested in the certification labs. So at the end, if you have power quality meter from 2 or 3 vendors, the results should be same. Here I'm mostly mentioning European standards, because from the power quality point of view, I believe we are much far than US or maybe or China or whatever, because we have the best definition of these standards. In the US, I believe they are just looking for a few harmonics and that's it. But in Europe, we have to strictly follow the power quality. So this is the definition how the meter should measure. And then you have the meter, you measure some data, and then you should evaluate these data. Then there are another international standards telling how these numbers, which are going from the power quality meter, are evaluated. So at first you have some raw data or some calculated numbers from the PQ meter, and then you should do some statistical analysis, check for each parameter, for example, if the voltage is plus minus 230 volts, and then you have some statistical evaluation for the whole week, if it passed or not. And this is done for each parameter. So at the end, for each parameter, you know if pass or fail. Also, in overall, all parameters must pass the power quality, then it passes in overall, I mean the power quality. For that, again, in Europe, we have a list of limits, which are, but we are this definition is widely used worldwide. So there is a list of limits for each quantity, and usually each national or international grid has its own limits. For example, sometimes they are more strict or less strict. It depends on the how the grid look like. So now let me speak a little bit about how the measurement is usually done. There are two types of the measurement: short-term measurement and long-term measurement from, let's say, the usage point of view. For the short-term measurement, you usually have a portable meter, some box with the sensors, with display, everything. You are putting this meter somewhere in the network, measuring like 2-3 weeks, and then you grab the meter and download the data, and you are doing your offline analysis in the lab. So you are personally checking a lot of parameters, doing some reports for the customer. You are doing the protocol after this 2-3 weeks of measurement, and you don't need any central solution. So for that reason, we have portable, one of our portable meters and the analysis tools I will talk about a little bit later. Then on the other hand, usually either the transmission or distribution system operators or the large factories, they need to measure continuously. So they are putting fixed analyzers, which are usually the devices mounted on DIN rail. There is no display, nothing. They are placed in the cabinet, mounted in the substation or at the input point of the factory, and they are connected to some kind of communication network using 4G modems or Ethernet. It depends on the substation, and they are installed for years. They are running continuously, measuring, having all the parameters and sending them to some kind of central solution. So some servers which are taking the data, and these servers are automatically doing some reports of the power quality, and they can even send the reports to the customers by emails or whatever. So there is no need for the operator to really analyze the data and think about the data, because this is the central solution. And in case something happens then, or the quality is bad, then the operator is checking the data with more deep analysis and other tools. For that installation, we have a solution called ENA NXG and ENA SCADA software. Let me talk quickly about the portable device. So over the last 20-30 years, we developed like 15 or up to 20 portable meters. The latest one now is called ENA 8000. So worldwide, mentioned this could be one of the best power quality meters. So it follows the latest edition of the power quality international standards, the highest precision. It can also work as a portable phasor measurement unit, which is quite unique. It has, as I said, high precision, but measuring up to 1 kilovolt. It's category 4, higher isolation. It can be equipped with a list of sensors for different current measurements, from few amps up to thousands of amps using Rogowski coils. In case of the waveform storage, it has very high sampling rate, up approximately 124 kilosamples per channel. It can measure higher harmonics, especially in a range of 2 to 9 kilohertz and 9 to 150 kilohertz, which is also quite unique worldwide, because there are just 2 or 3 competitors which can make a similar portable meter. It has a battery, display, large storage, GPS, whatever. So it's quite a strong tool to analyze the data. On other hand, for this portable meter, we have large offline analysis tool. So you are measuring with the meter, and then you are doing a lot of evaluation. So you can do some graphs, complex spectra, doing your own protocols, doing really a lot of analysis or exporting data to Excel or PQDIF. So this is the solution when you are using your portable meter and doing some kind of, let's say, analysis somewhere for 2-3 weeks or 1-2 months maximum, and analyzing the data. Then, as I said, we have two types of measurement. The second one is doing the analysis or doing the measurement in long-term view over the whole grid. So you need like hundreds of meters over the whole country and measuring for like whole or all the time, like years. So for that, we developed the platform we call ENA NXG. So instead of having the exact meter, we call it as a platform. So we have a device which can be combined from different input modules. So at the beginning, the user can specify how many channels he wants to measure, like 1, 2, 3 phase systems or voltage and current. And then as we are doing the firmware also, so we can specify what should be the functionality, of the meter. So beginning with the hardware inputs, we have a CPU module, which does all the calculation, which has the storage, SD card, GPS optionally input, Ethernet, USB for additional data download. And then we have different input modules. First one, which is mostly used, is the module measuring directly the 3-phase voltage. So it has 4 channels, 300 volts RMS range, measuring up to 600 volts RMS, very high isolation. It's from safety point of view is category 4, 300 volts. So it can be placed in the cabinets which are installed outside. Then for sure, we have the direct current input module. So it can measure either 1 or 5 amps, which are the typical outputs from the substation CTs. Usually you have on the substation, you have the current, which is measured by the current transformers. And these current transformers are either using 1 amp output or 5 amp output. So our current module can either take 1 amp or 5 amp as a current input. But we have also another way of measuring the current. This is quite new and quite unique with the power quality meters. So we have a module which is equipped with 16 inputs measuring low voltage up to, let's say, 1 volt. And there is a new trend of current measurement. So instead of having CTs with 1 amp or 5 amp output, there are new type of CTs now produced by many vendors worldwide, which have 330 millivolt outputs from the current transformer. So in that case, we can measure quite low voltage, as I said, up to 1 volt. And we can measure the current indirectly with the current transformers from, let's say, 100 amps or 1 amp or whatever amp up to converting to 330 millivolts. So for that case, we developed an input module with 16 low voltage inputs. So just by one module, we can measure up to 16 currents. For sure, we can develop any other modules, or we can develop or prepare some connection terminals which can measure either quantities. But for the power quality, we are mostly focusing on voltage and current. Also, we can provide external connection block which can convert DC measurement. So if you have, for example, some photovoltaic plant and you want to measure the DC values going from the photovoltaic panels using the strings, and then you would like to measure also the AC values, for example, after the converter, you can use 1 meter, which can be measuring both AC and DC, and the DC should be measured using external connection block, which just converts the DC value to low voltage and then connect it to low voltage input module. So this was briefly about, let's say, the hardware structure of our measurement platform. So if I will go back to the first slide of ENA NXG, you can see different combinations of modules. So we have a device on the left which measures just 3-phase voltage and multiple currents using the 330 millivolt CTs, or on the right we have a meter which measures 3 times 3-phase voltage directly and many 3-phase currents. So really this gives us power to, let's say, prepare the meter based on the unique customer needs. So after we specified the hardware structure or the inputs of the device, we have some kind of functionality which we are uploading to the meter. So for sure, the power quality. So we are calculating all the numbers according to the standards I already mentioned. So voltages, currents, active, reactive power, frequencies, total harmonic distortion, all the energies, all the quantities are per phase and also 3-phase value. Also, we are calculating harmonics for voltage and current. We are capturing waveforms. So in case there is some strange situation, for example, some overvoltage or any other defined condition, we are storing directly the waveform of voltage and current. So later on, the analysis can be done directly on the voltage and current signals. Or we can combine many currents into one measurement box, and then we call it multi-feeder monitor. So for example, if you have a distribution transformer, so then there is just one 3-phase voltage, but you have multiple lines going to different streets or different parts of the city. So we are measuring one 3-phase voltage, and then, for example, up to 10 3-phase currents from each feeder, and we are measuring it by 1 meter, and we call this functionality multi-feeder monitor because we are monitoring multiple feeders going out. And also we are calculating all the power quality parameters, energies, everything. Or we can run the ENA NXG as a so-called phasor measurement unit. This is a device usually used by transmission system operators, and the meter itself measures very precisely phase amplitude and angle of each voltage and current phase, and sending it using standardized protocol into central software. So this is the PMU, and the PMU is used in so-called wide area monitoring systems. Definitely people from transmission system operators knows this functionality very well. And as I said, as we are building the firmware, we can mix all the functionalities somehow together. So at the end, we can bring the meter, which is very flexible from input points of view, but also from functionality point of view. as speaking about the data from the meter, we can provide it in multiple ways. Usually for the real-time values, we are providing it using Modbus or 104 protocol. For the historical values, we are trying to be the most open, so we are storing the data into CSV files stored locally on the SD card, and the data or SD card can be accessed by FTP protocol or SFTP or web services or some cybersecurity protocols if needed. So we are trying to be most open with this meter so it can be integrated into any third-party system, central system. And this is, for example, how the meter delivered with the cabinet look like. This is, for example, a demonstration, or this is the installation we did in Jordan for Jordan distribution system operator IDECO. So this meter measures 1 3-phase voltage and 8 3-phase currents using these external CTs. So it works as a multi-feeder monitor. We also equipped the cabinet with some converter to optical Ethernet, with fuses, power source, so we can deliver it as a fully equipped cabinet. So till now I was speaking about the meter for the fixed installation, and now let's talk a little bit about the central solution. So we have a software called ENA SCADA. At first, why we developed our own software? Because other central systems, they are really focusing just on measurements and not on the deep analysis, especially according power quality standards. So that's why we developed our own central software. In a few minutes, I will show you the real demo. So the central software reads all the historical and real-time data from the meters, displays it in multiple views, like different graphs, spectra, maps. I will show it later. It does automatic evaluation of all the data. It sends reports automatically. It stores the data into SQL database. It generates PDFs. So you can receive just an email with the evaluation of the power quality as a PDF. It has a supervision system and a lot of other features. It can run either directly on your servers if you have multiple meters, or we can provide it also as a cloud solution. But the cloud also, one of the machines of the cloud also can be installed in your country. So there is no need the data to go out of your country, but still it is a cloud solution. This is some brief description of the architecture. So we have analyzers, we have a central server which does all the job. We have the SQL server, and we have the clients then which are analyzing the data. For now, I will switch from the presentation to the live demo. So here you can see the application itself. This one runs in our own server, so I have access to there. And we have multiple meters inside. So for example, this meter is measuring our own building. So I have 3-phase voltage and then currents going to different parts of the building, like first floor, second floor, whatever. So here we can see some online values for these measured or for all the meters integrated into our system. We can see it as a graphs. So I will choose some meter and I shall see some numbers, but we are still talking about real-time values. So operators in the real time can check what is going in the grid, either checking voltage, current, whatever, selected quantities, active power or frequency. For sure we can change colors to some others. Or we can see online spectra of the meter. So here I selected first floor of our building, so I can see the vector diagram. I can see the spectra of voltage or current. Let's say in the real time, the delay is like 1 or 2 seconds. So this is still the online values, or I can see the map. For the map, I can see either real-time values of measured quantities, also with some coloring scheme. So in case your voltage in part of the grid is out of limits, then it changes the color, it's fully configurable. Or I can see some own layers. So for example, I can see the grid itself. So if we have files, GIS files defining the grid, then I can draw the grid into the map directly, or having some kind of icons where I can really go directly into each meter, and I can select the meter and switch to some selected visualizations. For example, the vector spectra as I showed before. So when I click here, then the panel should show me my meter directly. The map is quite unique, especially if you have many units. As I said, for example, in Jordan, we installed like 300 meters, and for them it's very difficult to realize the names or numbers of the meter. But when they look into map, then they directly know, I mean the operators directly know what they want to check and analyze. So they are going from the map directly to the data analysis or some kind of reports. This leads me to historical analysis also. So from historical point of view, as the central system is communicating with all the meters and downloading the data, so later on we can choose selected measurement points, select some quantities, and then put them into the graphs. We can compare multiple meters in one graph. So now I choose the voltage and active power of one of our floors in our building. I can choose like last week instead of yesterday, or I can choose any other time frame. So here you can see that the active power is going up each working day, and then during the weekend there is nothing or almost nothing. For the voltage, it's still stable for sure. So I can put here multiple measurements. So I will also put, let's say, the second floor of our building, again, voltage and active power. You see we have multiple measurements, a lot of parameters measured, so we can put many things into the graphs. So for now, I will hide the voltages and I will focus just on active power, total one. So I have the total power from first floor, and then total power from the second floor. I will change just the color to understand which one is which. So by this, I can compare between two powers from two, let's say, measurement points. And it's really up to the operator how many quantities are placed here in the graphs. For sure, I can select like not just 1 week, but like 1 month or month and a half. And then we will see the larger scale of the time frame. So it's really quite open. Anytime I can export the data to CSV file or Excel or directly to the PDF. So you should have your own report whatever you need. So now we can see active power over, I think, like 1.5 months. So this was the showing how the historical graphs are provided. We do the same for the FFT. So I can just choose the meter and time frame, and then I see the spectra from selected time frame. So again, multiple measurements can be placed here, and we can play with the y-axis, display different data. One interesting thing, or one of the interesting things, is also the power quality. As I said, the power quality is evaluated or measured by the meter and then evaluated statistically. So here I can see the statistical results for all my meters calculated each week automatically. So for example, for my building, I see the power quality is not passing because of bad quality coming into our building, the total harmonic distortion and the harmonics are not following the limits. So I directly can see the red cross that the power quality over each week of this year didn't pass. So I will disable THD and harmonics in the evaluation, and then I can simply see that also the flicker in our building is out of the limits. Unfortunately, we have quite bad quality, but now we can see that first weeks of this year, all of them passed. Then in week 14, 15, again, and when I click on it, I can see also the short time flicker didn't pass. So this is the overall analysis. If I want to see the deep analysis for each week, I can select the week and show the details. And then, as I said, we can see the statistical analysis for each quantity. So I was talking that the frequency should be in some limits. So we passed all the limits. The voltage should be in some limits. Flicker should be in some limits. And here we can see that for this selected week, the long-term flicker was out of the limits. Also the unbalance, which means that the three-phase system is correct, THD, and particular harmonics. So you can see that we have problems with third, fifth, and ninth harmonic in our building. So our electricity is quite bad. So this is the overall analysis of the power quality. Also, this is automatically evaluated as a report. So if I will display the report list, so I shall see power quality report for our building. This is the PDF generated automatically, and it can be sent to you by email. So each month or week for each measurement point, you can configure that you will receive the PDF report. Or, as I said, we are also capturing some waveforms. So in case of the waveform is captured in the grid, so then you can directly receive the PDF with your data, or for sure you can analyze it manually in the event list. So I can open the event list, I can look for selected events, and then I can do some deep analysis, checking the numbers. So for sure, the meter should measure everything, and then the central system gives you the tools how to analyze. I know that we are quite short in the time, so maybe last thing I will show before going back to my slides is the energy evaluation. So here I can select some particular meter, select the type of the energy I would like to see, and I can simply see the consumption over a week or month or whatever. Accumulated by hours or days. again, as it is in the database, then also any third-party system can take it by SQL commands if they have enough rights for that. And there are really many other nice features in the software, but we are quite short in the time, so I will just go back to my presentation. Later on, my colleague Michal can share the presentation with you if you are interested, so he can send it to you. So I will just go quickly through the screens I already showed to you. So one of the last slides are the references. As I said, we are quite active worldwide, but sometimes it's not easy to get into transmission or distribution network in other countries. So the largest installations we either have in the Central Europe, but also in the Middle East. So as I said, we have the nice pilot project in Jordan when we are monitoring 300 distribution transformer stations. So each station we are monitoring multiple feeders going out in the low voltage network. But also we are active in United Arab Emirates, where we installed for the Transco, which is a transmission of the whole UAE. We delivered actually like 15 power quality meters and also the central ENA SCADA system. We are active there from, I think, 2005, when we were asked to help them monitoring frequency, because in that times they were the island grid, so not interconnected with other countries. So they were struggling with the frequency, and we built them special monitoring system and the central software to monitor frequency. And from that time, it's really converted to full power quality. So these are just the selected references. Actually, we are trying also to, or we are working on the pilot project in Switzerland with ENA and XG, which is quite prestige for us, because in Switzerland, you know, they developed a lot of energy measurement techniques and softwares, and we can still beat the Switzerland companies with our ENA SCADA and ENA and XG solution. So I was speaking quite a lot, so maybe now is the time for some questions and discussion.
Thank you, Dr. Jiri, for this interesting presentation. شكرا دكتور جيري على هذه البرزنتيشن الممتعة والتي استعرضت فيها التكنولوجيز الرائدة في مجال قياس جودة الطاقة الكهربائية. الآن أفتحها إذا كان عندكم بعض الأسئلة للحاضرين. هناك بعض الأسئلة التي تسأل عن attendance certificate أو شهادة الحضور. نعم. So يمكنكم التواصل معي مباشرة عبر الإيميل. So Dr. Jiri, can you like switch to the next slide?
Sure.
Okay, so هنا ترون my mobile number and my email. So أتمنى عليكم أن تتواصلوا معي مباشرة وترسلوا لي اسمكم، اسم الشركة، complete information تبعكم لكي أستطيع أن نرسل لكم شهادة حضور مع ال PDF presentation إذا ممكن. أوكي. الآن في حال كان عندكم أسئلة نحن جاهزون للإجابة عنها، فتفضلوا. Okay, so we have a question, Dr. Jiri. It was wrote down in Arabic. So they are asking about the battery, which is coming with the device,
yes,
with the portable device. Mm-hmm. Okay, so it works for 2 to 3 hours duration.
Yes, yes.
So can we use an extended battery or another one?
Not easily, because you know the meter is tested to be racked and certified also from safety point of view, so it's not allowed to exchange batteries inside, but I can imagine there can be some external solution like UPS or something. It really depends on the measurement and installation. But
Okay.
the meter itself cannot be extended by another battery. I mean, we cannot put it inside.
Okay. And is there any chance to like flexibility in terms of changing the battery life or exchanging or using a higher power battery?
This is something I should discuss with the hardware developers. But
okay.
actually, there is no easy way like removing and placing other.
Okay.
It's not working like this now.
Okay, excellent. So كان عم بيقول الدكتور جيري انه اجمالا هيدي الباتري ستاندرد بتجي معها، ولكن نحن منفتحين لاقتراحاتكم. ممكن نستخدم بطاريات عمر اطول، ولكن هذا يتطلب بعض الابحاث والدراسات الداخليه ضمن شركتنا وشركه الكوم. So بتمنى انه جاوبناك على السؤال. Okay. So كمان في there is another question. Now in Saudi Arabia, they are using smart meters. So can we use portable device to check the meter and issue calibration certificate, for example?
Well, I believe yes, because the meter is providing all the numbers like the revenue meter, so all the energies and whatever, and it's very precise. It also depends on the current clamps, but if the meter itself is calibrated, which can be done in any lab, like once a year, then you can check what is measured by the smart meter and what is measured by the portable one and check the difference. So I believe, yes, it can be used for such testing.
Excellent, excellent. الآن هل هناك أسئلة إضافية تريدون الإجابة أو نساعدكم للإجابة عنها؟ إذا لا أسئلة إضافية. شكرا لحضوركم. أنا بانتظار رسائلكم الإلكترونية الإيميلز أن ترسلوا لي your full details. So أتمنى أن ترسلوا لي your company name, your name and your mobile number and application. So we can maybe address or send you the certificate, or we can discuss any possible future project. So يمكننا مناقشة مشاريع إضافية بالوقت المستقبل القريب. هناك سؤال إضافي. There is another question, Dr. Jiri. Is there any challenge or because there is no current project or exist a new or system in Saudi Arabia that you didn't install yet?
No, we didn't install anything in Saudi.
Okay, so I guess I have an answer. عندي الجواب. الجواب هو إنه recently Elcom and Saab يعني we started working on بالماركت بالسعودية العربية، وحاليا نحن اشتغلنا بالميدل ايست، باليو اي اي اشتغلنا بالجوردن، وحاليا عم نشتغل نيو بروجكت بالمملكة. Some of them are confidential but soon ان شاء الله حتسمعوا عنهم. بس نحن ready to set up من اوائل or SCADA power application لإلكم بالمملكة، ونحن مستعدين لأي تعاون قريب ان شاء الله بشكل انه نحقق الاهداف المرجوة. It's not a price issue at all. However, there was some maybe marketing strategy that now we are now focusing on Gulf region and for Saudi Arabia as well. And hopefully soon you will see materialized project that could be installed and deployed in Saudi Arabia. So no more questions. Okay, excellent. So thank you for your time. Our event or our webinar reached its end. Thank you for all your questions, feedback, and most importantly, thank you for your time. We were honored to have you in our event, and please reach out to me for any questions. We will be more than happy to hear your problems and provide you with the right solution. أتمنى لكم نهار موفق و enjoy your day. شكرا للجميع.